Hey everybody, we're going to talk about notes from the 7th grade Common Core lesson 6.4. We're going to be going ahead and using equations to solve percent problems. Proportions can also be used, but today's notes are all about equations. Typically we use the equation part is equal to whole times percent. But it's important to remember that when you're putting a percent into an equation, that percent has already been written as an equivalent decimal. So in example 1, it says, what is 25% of 50? We go ahead and we translate that into an equation. What is? They're saying they don't know. Is the same as equal. 25% of 50. Of represents the multiplication part. And I'm going to change 25% to a decimal. So I am multiplying 0.25 times 50. When we go ahead and solve that, we typically don't want the variable to be standing alone, but because we're simply translating, it's okay in this situation. And then I go ahead and I multiply 0.25 times 50, so that's a fourth of 50. So I'm taking 50 and dividing it by 4, or multiplying 5 quarters. For 12.5. Okay? If at any time I have to go ahead and I have to doodle this, I can do that off to the side. So I've gone ahead and I've translated using the words to create part is equal to whole times percent, percent written as a decimal. And these are interchangeable because of the commutative property of multiplication. Let's look at example 2. 9.5 is what percent of 25? So 9.5 is equal to what percent, I don't know, so I use a variable, of 25. I'm going to go ahead and rewrite this as 9.5 equals 25x. I have a one-step equation in which I'm going to solve by dividing by 25. X is equal to whatever 9.5 divided by 25 is, and I am going to doodle this off to the side. 25 goes into 95 3 times, and that's 75. I have 20 as a remainder, and I can't have that. So now I want to know how many 25s are in 500, and I could look and say of how many quarters are in $2, and that's 8. 40, 16 plus the 4 is the 20. So x is equal to 0.38. It's important here to use your 4 close reading strategies because I'm finding a percent. X is equal to 0.38. So that means the percent answer is 38%. So don't forget that last part that you may be solving for X, but that may not answer your question. So I've translated 95 is equal to X times 25. I've written it as an equation. I've solved the equation. I've solved for X, and now I've translated it into the actual, I've answered the actual question of changing that back into a percent. In example 3, I have 39 is. So 39 is equal to 52%, which I write as a decimal, of something. I don't know, so I use a variable. I then go ahead and solve this equation by dividing by 0.52 on both sides. X is equal to 39 divided by 0.52. I'm going to go ahead and doodle off to the side that 39 divided by 0.52. Can't have a decimal point in my divisor, so I'm going to move it over 2 by multiplying by 100. So the real math problem I'm going to do is 3,900 divided by 52. And in doing that, I've created an equivalent expression. And so now I got to do some really good math here. 52 goes into 39, it doesn't. 52 goes into 390. So I'm going to say that 50, 100, 150, 200, 250, 300, 350. So I'm going to guess about 7, 14, 35, 36. I have now 26, bring down my 0. I know it's going to be less than 7 because I'm left with 260. And so I'm going to guess about 4 because I know that's, or I'm going to guess about 5 because that's about 250 with my 1. Right? So x ends up equaling 75. And then I go back and I say, all right, not looking for a percent because it's what number? So 39 is 52% of what? 75. When we're setting up equations, we're using part is equal to the percent times the whole, and that percent is written as a decimal. These are problems that are strictly translating problems. You will have to use inferencing in order to go ahead and solve up equations, set up equations that go ahead and have real-world problems. So be sure that you understand the format by stopping and starting the video, writing notes on the side for class, or sending emails. Thanks, guys. Have a good one.